Hi everyone, I'm Freddie Darbyshire, the Digital Commercialization Lead at Shell. It's great to be with you today. The topic of my session is AI making energy smarter. And in essence, this topic describes the focus of all of our AI efforts at Shell. As an organization, we are in the midst of rapid change. We believe the energy transition and digitalization are two of the key megatrends which will affect the world in the coming decades. In this context, AI technology is making our existing assets more effective and efficient, helping to maximize our returns and to minimize our CO2 footprint, whilst at the same time supporting development of our next generation of clean energy technologies, focused largely, but not exclusively, on electrification. So let's talk about how digitalization and AI are driving efficiency in our existing businesses. Within Shell, the pace of digital adoption is accelerating at an almost exponential rate. Just a couple of years ago, we had only a few robots in the field. Drones were relatively novel. RealWare was in its infancy. We had only a few thousand rows of data in our data lake and tens of machine learning models in production. So far this year, over 50 AI-powered applications have been deployed across Shell's businesses, with many more in the pipeline. And we have reached over 1.3 trillion rows of sensor data in our data lake. That's 1.3 trillion rows. We are monitoring over 6,000 pieces of equipment using machine learning across 23 assets in upstream, downstream manufacturing, and integrated gas businesses. We have equipped around 5,000 of our frontline workers with mobile devices across 20 assets, and we have flown over 1,200 drone missions, and robots have conducted over 100 cleaning and inspection jobs. Since the onset of the COVID-19 global health crisis, our use of virtual rooms powered by augmented reality technology increased by around 600%, with now over 100 devices being used in 30 locations. The AI-powered loyalty program, that's Go Plus, has now 1.5 million registered users and 26 million digital rewards have been issued. We are building up our internal capability with a team of around 350 in our digital center of expertise, a Shell.ai network of over 4,000 Shell staff and 800 citizen data scientists working AI solutions. We also see the pace of adoption of digital technology accelerating further with COVID. This is not unique to Shell. COVID has been first and foremost a humanitarian tragedy. And of course, it's had a huge impact on economies, companies, and people's livelihoods. Like many of you, I have been working from home, together with most of my 83,000 colleagues, and in many ways, digital technology is becoming an increasingly critical enabler for our business continuity. Let me share some examples. We are deploying robots to help keep our people safe and out of harm's way. For instance, engineers are using a remote-controlled vessel in the Norwegian Sea, about 120 kilometers from land, to inspect the Ormenlange gas field. In previous years, the crew of an adapted fishing trawler went to sea and collected data from sensors on the seabed. But now, our engineers are doing inspections from their homes in Dublin, doing nothing more risky than click a computer mouse. The robot's satellite broadband connection and video camera let the experienced mariners take the virtual helm without breaching potential COVID-19 lockdown restrictions. At the gas field, the robot communicates with the acoustic modems of seabed sensors, checking for possible subsidence. The data collected reaches the geophysicist working from Texas long before the robot returns from its 3-day mission. This experience exemplifies some of the shifts our people have been able to take, moving from knowing about technology to actually using it. Another way in which we're helping to keep our workers safe is by using augmented reality for remote inspections. Our augmented reality remote assist apps enable workers in the field to get assistance from experienced technicians or experts via a video call. These experts can be located anywhere in the world and will see what the worker is seeing and be able to provide guidance in real time. This is not only important for our own operations, we have also provided these devices to support our customers. For instance, in Malaysia, a power plant customer needed advice when their equipment broke down. Our team had sent a pair of smart glasses to the plant. Our technical experts working from home in Malaysia, the Philippines, and Singapore virtually walked through their plant. In this way, they were able to examine the faulty equipment through the customer's eyes and provide real-time remote help to fix the problem. Digitalisation is also embedded in how we optimise our assets, making them more efficient. Proactive technical monitoring integrates people, processes, and technology, allowing us to find small and fix small, thereby minimizing process safety and reliability risks. In 2019 alone, proactive technical monitoring helped Shell deliver about $130 million in a digital revenue due to avoided production deferments, maximizing availability throughput, and improved product quality. We are now enhancing this with AI. And predictive maintenance enables us to leverage over 1.3 trillion data points through machine learning to detect any anomalies. We're collaborating with C3.ai to provide this scalable artificial intelligence platform, and together with Microsoft, providing a cloud environment. We monitor about 2,000 pieces of equipment in our operating assets over upstream, downstream manufacturing, and integrated gas using this AI technology. This helps us maximize the utilization of our assets, thereby lowering cost as we can plan work more efficiently. But AI can also help us optimize the performance of our assets given production input, temperatures, product mix mode, or ongoing plant constraints, hereby increasing cash flow whilst reducing CO2 emissions. We use the C3.ai platform not only to predict equipment failure, but to optimize our asset performance. Take real-time production optimization, for example. Here, the algorithm is fed information from sensors like pressure, temperature, and flow rates, and then calculates the optimum setting to safely maximize the efficiency of the system. At the same time, it handles operational, economic, and engineering constraints. In practice, within one of our world-class LNG assets, multidisciplinary teams have adapted existing RTPO technology, incorporating AI models specific for their operations, yielding a 1 to 2% increase in production per year. This is all without any additional CapEx investment. This optimization has also shown potential to help to reduce CO2 impact. And it allows us a different organizational model because the optimization can take place via central hubs supporting a number of assets. We are integrating this data into digital twins too. A digital twin is the virtual representation of the physical elements, equipment, instruments, etc., and the dynamic behavior, as represented by models, of an asset over its life cycle. We are rolling out digital twin technology across our assets, and it provides the integration, visualization, and analytics capabilities that bring with them a new era of visually interacting with data and models at the asset, equipment, and component level. This drives efficiency by enabling remote operations, increased automation, and significantly improved collaboration. The data and models are coupled with interactive visualizations which make it possible to simulate real conditions and apply the insights to help optimize things like maintenance, inspections, then to do proactive interventions and so forth. Digital Twin is already live in Nyhamna gas plant in Norway, and deployment is underway in 5 other assets at the moment. The Shell.ai platform also supports our global carbon abatement tools. And these tools have sophisticated algorithms to help Shell businesses identify the most impactful capital investment opportunities for reducing operational emissions across the entire portfolio. The tools capture technical and financial information about possible abatement projects at each asset, and this helps Shell to identify, rank, and select the most effective reduction projects. But it's not just about improving our existing business models. We are also using AI to ensure we develop adjacent services for our customers and our new businesses as their focus changes too. For instance, we're using AI in conjunction with lasers to monitor carbon capture and storage at our Quest facility in Scotland, which has now safely stored more than 5 million tons of CO2. Shell sees CCS as one of the big levers to meet our carbon ambition, supporting hard-to-abate areas of the economy like cement factories, refineries, and steel production facilities. As we create CCS solutions, digital technology is going to play a massive role. The monitoring at Quest involves an innovative sensor system at the injection well site to assess the atmospheric gas composition and to identify possible carbon dioxide emission events. The system uses machine learning algorithms to distinguish actual carbon dioxide events at the facility from the background noise of normal atmospheric variations. Another example of a new service for our customers is Shell Remote Sense, which helps operators of large engines understand when issues are about to occur. Good lubricant management is vital for keeping critical machinery healthy and operations running smoothly. Shell has over 30 years experience providing oil and equipment condition monitoring, and we analyze over 750,000 oil samples every year. With Remote Sense, we gather oil performance data using sensors before processing this data in an AI workflow to offer real-time condition monitoring. This helps customers to reduce unplanned downtime, optimize maintenance, and extend equipment life. It therefore has a significant value for our customers as it reduces their risks. Personalizing the customer experience is also a critical focus for our AI efforts. In Shell, we are constantly assessing new use cases, from using machine vision to inspect pipelines, to natural language processing techniques to trawl exploration archives and reports. But perhaps the most exciting area is the customer domain. As our customer and consumer-facing businesses grow with the acquisition of new power companies like First Utility, which has since been rebranded to Shell Energy in the UK, and New Motion in the Netherlands, we have an opportunity to build deeper relationships with our customers. As such, we are developing new types of AI solutions to help understand our customers' needs, patterns of energy consumption, and the way they interact with Shell. We've also deployed an AI-powered loyalty program. The work we've done with Go Plus, or with the Go Plus offer in the UK at least, is transformational. It uses generalized information and machine learning methods to identify individual customers' preferences and to reward them in kind. The machine learning in the app responds to feedback, learning from rewards the customer prefers to select, as well as drawing inference from the things that they do not. This platform also allows members to offset their carbon emissions from fuels through nature-based solutions. Already, over 1.5 million customers have signed up, and more than 26 million rewards have been issued. It is all powered by AI, which is underpinning all the offers that our customers get every day. This is helping our customers to be greener and is changing the way they consume and manage energy. It's also important to recognize the key role that AI is going to play in enabling the next generation of clean energy technology. Shell offers customers access to over 165,000 charge points around the world, and this already makes Shell one of the world's largest providers of electric transport solutions. From an AI perspective, we are bringing charging and consumption data together to allow us to understand core charging profiles, essentially helping us to understand how customers charge their vehicles and to optimize the vehicle charging process itself. This is to both save customers money, but also to protect the grid. And we are already deploying these smart charging capabilities through hundreds of charge posts, with the expectation that we will roll it out to hundreds more in the coming 12 months to large fleet and also to commercial and industrial customers. The complexity of decarbonizing industries such as steel or cement manufacturing is also immense. Most industrial reactors burn hydrocarbons to provide the necessary heat for the chemical reactions to occur, and this produces carbon dioxide emissions. Increased energy efficiency and substituting hydrocarbon fuels with electric heating or hydrogen burners could make these reactions carbon neutral. So Shell is developing new reactor designs with various partners using computational fluid dynamics. The approach, if successful, will have numerous replication opportunities and could transform processing across many industrial sectors. Shell is also working to develop more efficient electrolyzers, which are devices for splitting water into hydrogen and oxygen. The modeling challenges are large, from the scale of molecular interaction up to the electrolyzer unit cells, and the large-scale interaction or integration of electrolyzers into a distributed electricity grid. We create digital models of these electrolyzer pilot plants to generate design insights and help boost operational performance and grid integration opportunities. Another aspect to the hydrogen economy is the safe storage and transport of hydrogen fuel. This presents several technical challenges that Shell is addressing with AI, for example, by developing new container designs to increase the safety of operations and enable more widespread adoption of hydrogen as an energy vector. We are also using AI in the area of renewables such as wind farm development. Developing a wind farm is a complex business with many variables, from selecting the location of the turbines, where to place battery storage and subsea cabling, etc. For construction logistics decisions, we are using technology not dissimilar to the one we use to optimize our LNG logistics. And this brings me on to my final point, how we approach all of this work. You may have seen that we recently ran a new hackathon around wind farm optimization. We recognize that whilst we have developed a strong internal capability in the area of AI, we need to work with others, customers, partners, startups, academia, and the wider digital community. Digital technologies change the way we work, and we need to embrace that change. So why is external collaboration such a vital aspect of our work in developing AI technology? Well, simply put, we have to rely on each other's strengths. For example, Microsoft and Shell have a multi-decade history of working together, addressing industry challenges and opportunities. Last year, we announced a strategic alliance to help drive transformation of the energy sector, support a net zero emissions future, and deliver new solutions to customers in support of their own energy transition and carbon reduction ambitions. The work we do together will help Shell suppliers decarbonize. And Shell is already leveraging Azure to build a digital tool to track supplier emissions, show baselines, set targets, and develop plans for customers' own operations to achieve these insights. These tools will help to create transparency of a company's energy consumption and ability to cross-reference with regulatory frameworks. Both Microsoft and Shell will also work together to help small to medium-sized companies conduct carbon footprint calculations. The Alliance will also explore ways to help these companies find and access low-carbon solutions and products, along with guidance to help them make the most effective carbon reduction choices. Another interesting AI collaboration story to share with you is that Shell, C3 AI, Baker Hughes, and Microsoft are also collaborating on the Open AI Energy Initiative. This is an ecosystem for AI solutions to help the energy industry's digital transformation. By bringing our solutions plus many others to market and creating an interoperable ecosystem framework with the building blocks to help others do the same, we hope to accelerate the adoption of AI technology across the industry. The OAI provides an open framework for building these interoperable solutions, such as AI and physics-based models, diagnostic libraries, and services, and we're excited to offer these capabilities to the market and participate in the creation of an open ecosystem that can benefit the entire industry. And finally, as an enterprise, we are making sure we focus on the change and learning elements to embed AI technology at scale. Digital tech and AI are becoming core to our business, and we need to run this as a change program that aims to embed it into everything and every facet of what we do. The Shell AI program is a program that was set up in 2013, and it's grown since then. It's designed to embed AI technology into all parts of our business, and we now have over 4,000 people who are part of the Shell.ai network. Many of them are citizen data scientists, people who have, for instance, an engineering background or a chemistry degree. And engineers are our assets who want to learn about how AI technology can change the way in which they do their work. These people are the ones who are going to make the difference as they see the opportunities which can be unlocked with the support of our professional data scientists. Therefore, we have focused very hard on enabling this community. We run multiple sessions a month. We have 800 citizen developers and citizen data scientists. We run annual awards to incentivize these people to continue to innovate and to continue to bring great ideas that allow us to build some of the products that I've described today. It's also about trying to get the commitment of Shell leaders to allow these people to reskill. Everyone in our organization is going to have to learn to adapt to new digital technologies. So what we need to do is embrace the continual learning and the continual development requirement. As such, we have partnered with Udacity to build a coherent upskilling program to skill citizen data scientists and professional data scientists, as well as engineers with the modern development skills that they need to develop professional digital products. And it's paying off. Digitalization has already enabled more than $1 billion of cost reductions, production increases, and increased customer margins across Shell's businesses, and that's per annum. This is growing fast. It's still early days, but it will increase significantly in the years to come. We see that in the future, this is going to become part of every product, service, and solution which Shell provides to the market with our customers and industry partners. So you see, we're going through a transformation. We are excited. We're excited by the capability and the community that we are building. We're excited by the impact that our projects in AI are already having. And most of all, we're excited about the potential that we have yet to realize from this emerging technology. That closes my session today. Thank you very much indeed for your time, and I hope to speak to you soon. Bye-bye.